Today I'm going to talk about some of the other techniques you can use when simplifying trig expressions. So I'm going to be walking you through some of these odd problems on page 452. So this is number 27. And the first thing I say over here is let's write things in terms of sine and cosine. So I took tangent and wrote that as sine of x over cosine x. I took cotan and wrote that as cosine over sine. But I want to add these two fractions, but they have different denominators. So that's when I'm going to have to try to find the least common denominator so I can add the expressions inside my parentheses. So I need to have a cosine sine as my common denominator. So I'm multiplying this left expression by sine over sine, cosine over sine, and that's going to give me my new denominator, sine squared, cosine squared. Now that they have the same denominator, I put the denominator down and I add them. And so by now you should know that sine squared plus cosine squared is 1. Now if I carry out my multiplication, my sines would cancel, 1 over cosine x, and you should know that 1 over cosine is going to simplify into secant x. You wouldn't leave this here because you realize that that is a reciprocal identity, so we'll turn it into secant x. All right, in number 31, I have a rather complicated situation. And some people might approach that in terms of sine over cosine for tangent, but I'm not going to do that. I have this on the paper and you can look over it, but I'm going to show you a simpler method that would work. There's no need to change your tangent x, just keep it in your numerators. But I can change my cosecant squared x, I can change my cosecant squared x up here in this denominator to 1 over sine squared x, because those are equivalent. And I can turn secant squared x into 1 over cosine squared x. Now I can kiss and flip, if you want to call it that way, or I can change dividing by this, multiplying by its reciprocal. So the reciprocal of 1 over sine squared becomes just sine squared x. So this is tan x sine squared x. When I kiss and flip here, it becomes tangent x cosine squared x. Here's where we're going to do that first factoring. Each of these terms have a tangent x in it, so I will factor that out, and I will be left with sine squared plus cosine squared, which I know is 1, and 1 times tan x just leaves me with tan x. If we move on to question 33, I have 1 over sine squared x plus secant squared x over tan squared x. And for the moment, I'm just leaving this alone because it doesn't look that complicated. This is the one that looks challenging to me. So I'm writing secant squared as 1 over cosine squared x. I'm writing tangent squared as sine squared over cosine squared. Here I'm taking and multiplying by the reciprocal, or kiss and flip if that's what you want to call it. And then I understand that my cosine squares are going to cancel out there and I'm left with 1 over sine squared. Oh man, that's what I had over here to start with. That is a reciprocal identity. So 1 over sine squared turns into cosecant squared, so that makes 2 of them. Next, I am going to try question 35. And I'm leaving the sign here. I'm rewriting cotan squared as 1 over tan squared, because that's true. Cosecant and 1 over tan squared are equivalent to each other. Dividing by this expression becomes multiplying by tangent squared. On this side, I had sine over cosine squared. So if I want to simplify this complex fraction, it becomes sine x times 1 over cosine squared. And this expression is equivalent to secant squared. This expression is equal to secant squared because 1 over cosine is secant, and it would be squared. So now I'm left with a sine x times the tangent squared x minus the sine x times the secant squared x. This is where factoring comes in again. I see a sine x in each of those. So if I factor out the sine x, I'm left with tangent squared x minus secant squared x. Now this is on you to recognize that that's a Pythagorean identity. If I go back to that Pythagorean identity, 1 plus tangent squared equals secant squared. And if I move the secant over and subtract it and move the 1 over, it becomes negative. So tangent squared x minus secant squared x is really equivalent to negative 1. So all of this is negative 1, and negative 1 times sine x would just be the opposite of sine x. In question 37, I have secant becomes 1 over cosine, and dividing by sine becomes multiplying by 1 over sine. Right now I'm just working with this side of the expression. And that becomes 1 over cosine x sine x. When I simplify this complex fraction, I get 1 over cosine x sine x. And then this one was sine x cosine x. I didn't do anything with it. Just like one of those previous problems, if I want to subtract these, I have to have a common denominator. So I need this extra sine x to show up in this denominator. So I'm multiplying by sine x over sine x, which gives me sine squared in the top, leaves me with my common denominator on the bottom, and 1 minus sine squared x becomes cosine squared x. One of the cosines will cancel with one of the ones in the numerator, and I'm left with cosine over sine, which you should recognize as cotangent.